Hello and welcome. This is a presentation on our work Latents2Segments, disentangling the latent space of generative models for semantic segmentation of face images. Multi-class semantic segmentation of face images is important for several AR/VR applications such as hair recoloring and virtual makeup try-on. Yet, there exist almost no prior methods which can perform this task in a prior agnostic manner. To solve this problem, we aim to build a generative model capable of regenerating semantic regions of interest from a given input image selectively. The lack of established relationships between the latent space of state-of-the-art generative models and regions of interest in their generated images makes this problem even more challenging. The objectives of this work are to disentangle the latent space of a generative model with respect to semantic regions of interest in its generated images, and to leverage the disentangled latent representation for generating multi-class semantic segmentation maps from face images. The swapping autoencoder forms the backbone of our model. It is a deep generative autoencoder which learns a neat distinction between the structure and style information of input images in its latent space, in the form of a structure tensor and a style vector. Our model is a parallelized version of the swapping autoencoder which uses its pre-trained encoder to encode input images into a style vector and a structure tensor. The structure tensor is then sliced as per the shown schema. Our model's architecture ensures that each slice of the structure tensor is representative of all the information required to regenerate a corresponding region of interest when all other slices are masked, and the masked structure tensor is decoded together with the style vector. This is done by feeding a set of masked structure tensors containing only one slice of information to a series of Siamese decoders which share weights and are supervised by images containing the intended region of interest only. Inferring the segmentation map for a particular region of interest from an input face image using our model amounts to a simple forward pass with appropriate masking applied to the structure tensor. Each Siamese decoder paired with the encoder is treated as a separate swapping autoencoder. An average of their corresponding composite losses is used to optimize the decoder weights. Here's a quick snapshot of experimental results on test images. The activeness compaction score quantifies the extent to which slices within the latent space of a generative model affect pixel intensities in only the intended semantic regions of interest in generated images. A largely diagonal average activeness map suggests a high activeness compaction score. Our model beats the state-of-the-art by a large margin in terms of ACS and returns comparable semantic segmentation accuracy while being 13% faster. Please find more details in our paper. Thank you for watching.